Hi, my name is Alex Sawatska, and this is Lab 3, Magnetic Field of a Bar Magnet, Physics 2, Spring 2023. The purpose of this lab is to measure the distance dependence of the magnetic field due to a small bar magnet, and then to compare that distance with the calculations of the distance dependence predicted by the equations of the on and off axis magnetic fields derived from the Biot-Savart law. For this lab, we will use the formulas of the Biot-Savart law and the natural log and the magnitude of the magnetic field of the bar. For the results, we found n to be negative 2.6847 and approximated r using the k constant. And we found that the magnetic field had similar values in both the glow script model and the experimental model. For the assumptions in this lab, we assume that the system is the Earth, the magnet, and the magnetometer. We also assume that the Earth and the magnet were the only forces detected and that no other magnetic or electric forces influence the magnetometer. We also assume that the phone orientation was along the north and south axis. The errors that could have occurred during this lab would be the assumptions above that would affect the results. The orientation of the phone could have shifted or not been perfect in the first place. There could have been human error in the measurements and also accidental movement of the magnet. Using the Excel file given to us and the magnetometer, we plugged in the distances and the values read by the magnetometer, and this gave us a value of the natural log of k to be negative 13.921, and then we use that to find the value of k to be 9 times 10 to the negative 7, and use the equation given beforehand to find the value of mu being 4.5, and then also the value given in the Excel sheet for n was negative 2.6847. For the glow script code here, we had to define the dipole moment of B, and then had to determine the vectors of the observation axis of each observation. And here you can see that the arrows being created as well, the white being the bar magnet at the origin, and the orange being the observation on axis 1 and 2, and the cyan being the arrow on the perpendicular axis, and then the magenta being the observation at the 45-degree angle. As you can see here, we got a D value of 0.353978. Here we ask what if we hadn't oriented the experiment to compensate for the magnetic north and instead just laid out at some random angle. We said that the results changed in the way that the net field would have stayed the same, but the magnetic field would be different across these separate axes, and the coordinate field would be adjusted according to the shift in the angle that occurred. Then we asked what if we were to stick two identical magnets together and run this experiment again, how that would change our results. Said that this would result in the magnetic field being greater than when we only had the one single magnet, and this is because of the combined electric force of the two magnets.